The 19th element on the periodic table of elements is potassium. I'm Mr. Norris from Norris Teaches Science, another physical science edition video, and today we're going to talk about writing chemical formulas, the actual process. So by the end of the video, you should be able to say, I can write chemical formulas following the rules for ionic, covalent, and polyatomic compounds. So here is the steps. So the first step is going to write the symbols. Whatever symbols are needed, write the symbols for the elements or write the symbols for the polyatomic compounds. Then you're going to write their oxidation numbers above the symbol. Then you're going to see if the oxidation numbers add up to equal 0. So -3 and +2 don't equal 0, while -3 and +3 do equal 0. Now that's where it gets tricky. If the oxidation numbers equal 0, just write the symbols next to each other. You don't have to do anything. But if the numbers do not equal 0, you're going to cross the oxidation numbers and write them as little subscripts on the opposite symbol. We take away the plus and minus signs because we do not need them in the formulas. Special note, when a 2 or 3 is being crossed down to a polyatomic ion, the polyatomic ion has to go around a parenthesis, and that little number goes on the outside of the parentheses. We're going to do a bunch of examples so you can see what I mean. So, for this case, most of the ones we're going to do are either binary ionic or they're polyatomic. Covalent is kind of easy because they give you the prefixes and everything just goes with that. So in the first step, you would write the symbols. Usually you are given the name of the compound, but this time we're going to start off with these first two by just going ahead and give you the symbols so you can get used to it. So pause real quick. Make sure you have your periodic table in front of you because you're going to need those oxidation numbers that we labeled in a previous video. So the first step is to write the symbols. Oh, they're already there. The next step is that we're going to write the oxidation number of each element above them. So Mg, if you look on your periodic table, you would know that it has an oxidation number of +2. And Cl would have an oxidation number of -1. Now we have to look at those. Do those equal 0? Well, they do not equal 0. So since they do not equal 0, you cross them. The 1 will cross down to the Mg, and the 2 will cross down to the Cl. So when you write it, you go Mg. Chemists are lazy, so we don't write the number 1 because they're always implied. And then Cl2. And that would be the formula for Mg and Cl, which would be magnesium chloride. When you've done this so often, you just start being able to look at stuff and know how to do it really quick. If you don't worry if you can't do that yet, I can look at these and figure these out. That way, I've been doing these for so long. All right, second one, let's do it. It says we have Li and F. It's two symbols, so let's so it would be binary ionic. So Li, we are looking for its oxidation number. We know that it's +1, and F is -1, fluorine. And so we have to look +1 and -1, that equals 0. When the oxidation numbers equal 0, you just take the symbols and you just write them next to each other. So LiF, lithium fluoride. Did you follow along? All right. I want you to try number 3 out real quick. Pause. If you can't do it, don't worry. I'm going to go over it. Pause real quick. I'm going to count to 5, and then I'm going to do it myself. 5, 4, 3, 2, 1. Here we go. So this time you are given the name of the compound, potassium oxide. So we first have to write the symbols. Potassium symbol is K. Oxide, remember in the name of the thing you changed the ending to IDE. Oxide is oxygen, so that's O. And then we're going to write our symbol, write our oxidation numbers above it. Potassium is +1 and oxygen is -2. Now, do they equal 0? +1 and -2, they're not going to equal 0. So that means we're going to cross the numbers. The 2 is going to go to the K, and the 1 is going to go to the O. So when we rewrite this, it's K2O. Did you follow along? Those were not that hard. They were just two elements. It's easier that way. Writing the names for binary ionic compounds is a little harder than writing the formulas. Remember how easy it was to write the names of the polyatomic compounds? If you don't, go watch that video. But writing the formulas is a little bit more difficult. So we have Ca and we have SO4. So SO4 is a polyatomic compound. So it stays together. We only have to look at its charge. And we have to look at its oxidation number. So Ca, if we go on the periodic table, it's +2. And SO4, if you go back to your polyatomic reference sheet, it would have said like 2- or -2 or something. That's its oxidation number. Now, do the numbers equal 0? Yes, it does. When that happens, you just write them next to each other. CaSO4. That 4 has to stay there because it's part of the polyatomic ion. All right, number 5, let's look at it. We have a polyatomic ion, we have an element. Now, we're going to write our oxidation numbers. Na is +1. PO4, if we look on the polyatomic reference sheet, is -3. Do they equal 0? No, they don't. So the 3, that means we cross. The 3 is going to go down to the Na. The 1 is coming for the PO4, the whole thing. When you write this, it's Na3. Chemists don't worry about the number 1. They don't exist. And so you just write PO4. All right. Example number 6. I would let you try this, but this one is a little bit complex too. You'll get a chance to do it on your own in a moment. All right. We got a polyatomic ion, we got an element, blah, blah, blah. Let's write our oxidation numbers. The oxidation number of Mg, magnesium, is +2. The oxidation number or charge of chlorate here is -1. Now we have to look, do they add up to equal 0? No, they don't. That means we cross. The 2 is going to come down for everything of ClO3. And 1's going to come down to Mg, but we don't deal with 1, so we just cross it out. So we have Mg, and here's where it gets tricky. If a 2 or a 3 is coming down in a cross to a polyatomic ion, that means the polyatomic ion will go in a parentheses, like this. You close parentheses, and then that oxidation number, or the number coming down, is going to go on the outside of the parentheses. And so you have Mg parentheses ClO3 close parentheses 2. I would rewind that a little bit, maybe watch it again, see what I did. All right. So next one. This time we have two polyatomic ions. It works the same way. We're going to just write the oxidation numbers. NH4 is +1 and NO3 is -1. Do they equal 0? They do. So we just write the symbols next to each other. Now we did not have to use parentheses here because a 2 or 3 was not coming down to either of them, but if that was the case, you would have to do that. I want you to pause the video real quick. I want you to try number 8 on your own. Hint, acetate is a polyatomic ion. Did you do it? All right, let's try it. First step is writing the symbols. So lithium is Li, acetate is C2H3O2. Then we write the charges, +1, -1, they equal 0. So we just write the symbols next to each other like this. Now if a 2 or a 3 was coming down to acetate, it would have to go in the parentheses with the number on the outside, but that's not what happened in this case. But I hope you learned how to write formulas. Watch the video again, learn it some more, practice it. You guys got this. I'm Mr. Norris, and I'm out for this video.